this video, we're going to have a look at travel graphs. Travel graphs are also known as distance time graphs. Travel graphs are line graphs used to describe the motion of objects such as cars, trains, walkers, or cyclists. Time is the independent variable and represented on the horizontal axis, and distance is the dependent variable represented on the vertical axis. Suppose cyclist 1 travels at a constant speed away from home, travelling 30 kilometres in 1 hour. First of all, let's label the units on our graph. Time will be in hours and distance will be in kilometres. Cyclist 1 travels 30 kilometres in 1 hour. This would be represented as a straight line graph as such, and we'll label it cyclist 1. The speed that cyclist 1 travels at, speed equals distance divided by time, is 30 kilometres in 1 hour, so it travels at 30 kilometres per hour. Suppose cyclist 2 travels at a constant speed away from home, only travelling at 10 kilometres in 1 hour. Cyclist 2 would be represented on the travel graph as such. Cyclist 2's speed is 10 kilometres in 1 hour, so 10 kilometres per hour. The slope, or the gradient of cyclist 1 graph, is steeper than cyclist 2, as they were travelling at a faster speed. The steeper the line, the faster the speed. Here is a graph of another cyclist journey to visit a friend who lives 40 kilometres away. In this first section of the graph, I'll label 1, the cyclist is travelling at a constant speed away from home. She travels 40 kilometres in 1 hour. The speed equals distance divided by time, which is 40 over 1 hour, which is 40 kilometres per hour. Again, we need to label the units of the graph, hour and kilometres. For the next 2 hours, at the second section of the graph, the cyclist is stationary. That is, the cyclist does not travel any distance while visiting her friend. A stationary object, or an object at rest, is always represented as a horizontal line. There's no change in distance with time. In the third section of the graph, the cyclist then travels at a constant speed back towards home. This takes 2 hours to travel the 40 kilometres. So section 3, the speed, distance divided by time, is 40 kilometres in 2 hours, so travels at 20 kilometres per hour. The journey to the friend was quite fast at 40 kilometres per hour, so perhaps this section of the graph was going downhill. Here are 2 further graphs without any units. The first shows an object travelling at a constant speed away from their starting point, then is stationary at the horizontal line, and then continues to travel away from their starting point at a faster speed. This is because this section of the line is steeper than the first section of the line before the rest. The second graph shows an object returning home at a constant speed. So you can think of the horizontal axis as the starting point or home. And that's a nice summary of travel graphs.